Welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and this video represents part 2 of our significant figures video series. So in the last video, we talked about what significant figures are. In this video, we're going to learn how to actually identify them and use them properly in our calculations. We're going to go over a few rules and a few calculation examples so that after this, you'll feel like a master of significant figures. Let's get started. So again, in part 1 of this video series, we talked about what significant figures are. We learned how to actually identify them, how to make sure we're measuring things properly, and what range of precision the different significant figure levels represent. So now in this video, we're going to be taking that information and understanding how we can properly identify what a significant figure is in a value, and then properly report the number of significant figures that a calculation may afford us. So just to recap, for significant figures, remember all non-zero numbers are significant. When we're dealing with zeros, leading zeros that come before the first non-zero number are never significant. Sandwich zeros or interior zeros are significant, and those are the ones that are between two non-zero numbers. And then trailing zeros are only significant if there is a decimal point present. And so now in this video, we're going to be talking all about how to actually apply these rules and think about these rules in terms of the calculations that we're going to be doing, okay? There's going to be two main sets of rules we're going to be dealing with. One for multiplication and division processes, and then the other for addition and subtraction. So when we're multiplying and dividing measurements, the significant rule is as follows. Your answer will have the fewest number of significant figures that's used overall in the operation. And so you're going to make sure that you write out all the numbers that your calculator spits out, but then you round at the end to show the appropriate number of significant figures. And so if you look at this example here shown for you, where we're taking 5.02 times 89.665 times 0.10, well, if we put that in our calculator, we get 45.0118 out. Now, the unfortunate thing is our calculators don't think for us. They don't know how to apply significant figures just yet. But it's very easy for us to figure out how many we should be reporting. So we go through and we look at all the numbers that were put into this calculation. And we identify how many significant figures each has. So 5.02 has 3, 89.665 has 5, and 0.10 has 2. Remember that first 0 is not significant because it's leading. And so what this tells us is that the answer will have the fewest number of sig figs used in the calculation. And so in this case, that would be 2. So remember that first 0 is considered leading, and so it would be not significant. So our final answer, although the calculator spit out 45.0118, we must make sure we round that to show the proper number of sig figs. And so here we would be taking and saying, well, we can only have 2 significant figures shown. So we would take this number and we would be stopping it after the first 2 significant figures, which in this case is 45. Because the 0 is not greater than 5, we would not round up, and we will leave the value as is to accurately show 2 significant figures. In the second calculation, where we have 5.892 divided by 6.1, the calculator spits out 0.96590. But we have to bear in mind that this answer should only have the fewest number of significant figures shown. So the first number has 4 significant figures. The second number has 3, which means our final answer can only have 3 significant figures. So in this case, we would not say that this represents one of our significant figures, because remember, that number represents a leading 0. So our count actually starts here with the 9. And we would count over 3 places, which gets us to the 5. Now, because the number after the 5 is greater than 5, we're going to end up rounding our values up to end up with the final answer of 0.966. So again, multiplication and division, your answer will have the fewest number of sig figs used overall. With addition and subtraction, there's a different set of rules. So in addition and subtraction, your answer is going to have the fewest number of decimal places that were used in the calculation. Okay, decimal places, not significant figures. And so again, if we look at the example shown to us on the right, we can see we have a very simple mathematical operation being done, and our answer ends up being 5.4125 when we plug that in the calculator. But our answer will have the fewest number of decimal places used overall. And so when we look and drop down how many decimal places are being used in each of these numbers, there's only the lowest amount would be 2 in that 0.07. So your final answer would only have 2 decimal places and overall have a total of 3 significant figures. Same thing on the second problem shown. Your final answer in this case would have the fewest number of decimal places used. So you would only have 1 decimal place shown. And again, we're rounding up in that case because you're ending up greater than 5. Bear in mind with rounding, if the number that comes after that last significant figure is less than 5, you're going to round down. So you'll keep it as is. If it's greater than 5, you're going to round up. Now, really, really important is this last statement here is that when you're dealing with mixed operations, multiple steps within a single problem, to avoid error, make sure you do not round until you get to the very end. You want to carry all of your numbers through, but just track where you would have stopped and apply everything at the end. If not, your excessive error can cause your values to shift slightly. And when you're dealing with mixed operations, we're going to use our please excuse my dear Aunt Sally, or the order of operations to help drive the steps that we should be following. All right, and so you can see here in this example where we have some mixed operation. So the parentheses is what we would be focusing on first. So if we focus on that parenthesis portion here, we see when we plug this into our calculators, we end up getting 3.37 out. But if that was the final part of the problem, the 5.67 minus 2.3, if that was the problem that we were solving, the rule we would be following is the fact that we're looking for the fewest number of decimal places, with that being a subtraction step. So we would, in theory, want to cut off there because there's only 1 decimal place in that 2.3 value. However, this is not the end of the problem. So when I'm saying carry all the numbers through, you're going to write down all the numbers, but just indicate to yourself where you would have stopped. So in this case, we would have stopped after the 3 and rounded up, but we're not going to do that just yet. Well, what that helps us to do is helps us to think about how many significant figures truly are coming into that subsequent step. So now if we're cutting it off after the second 3, then that means that there's a total of 2 significant figures that are coming through. So then in this final operation where we are taking 3.489 times 3.37, we end up getting, actually in the calculator, 11.75793. But if we're only now showing 2 significant figures, because the rule with multiplication is that we are using the fewest overall, we would cut it after the second 1, and then we round it up to the 12. And so again, round at the end, just track where you would be. All right, so let's do a few problems here. In the first problem, let's go ahead and plug it in. Again, it's all multiplication and division, so the rule we're going to be looking for is fewest significant figures overall. So we're going to start by doing 1.10 times 0.5120 times 4.0015 divided by 33.4555. And that gives us, the calculator spits out 0.652190653. However, we know that we're only going to be looking at reporting an answer with the fewest number of sig figs used overall. So in this problem, we have this number, we have 3 significant figures. This one, we have 4. Again, that leading 0 is not significant. This one, we have 5. This one, we would have 5 as well. So our answer is going to have the fewest, so 3 significant figures. We would end up not counting the 0 because it's leading. And we would count the 6, the 5, and the 2, and we would stop the number there. So our final value that we're going to report out is 0.652 with no rounding. In the next example, where we're adding and subtracting, we're going to take 0.355 plus 105.1 minus 100.5820. When we do that, we end up with 4.873. And the rule here is that we're going to be using the fewest number of decimal places. So with decimal places, we can see this one here, we can see that this one here only has 1 decimal place versus this one having 3 and this one having 4. So therefore, our final answer should have only 1 decimal place. So that means we're going to stop it after the 8. As the 7 that comes after the 8 is greater than 5, we will end up rounding up, and our final answer would be 4.9. In the next example, we have some mixed operation occurring. And so we're going to first focus on our parentheses aspect according to Please Excuse My Dear and Sally, our order of operations. And so that process is subtraction. So we know that our answer will have the fewest number of decimal places used. So I'm taking those 2 numbers and subtracting. When I do that portion, I get 0.3455. And if that were the end of the problem, we would have stopped 2 decimal places in and rounded up. But because this is not the end of the problem, I'm just going to write down what I have, indicate what's coming through, but I'm going to carry every single number through to the next step. But just remember what's going on here. So then I'm going to take my 4.562 times 3.9987, and we'll then divide it by 0.3455, all the numbers. And the calculator now is telling us that this overall is equal to 52.79904,313. Now with the significant figure rules, we got to think how many are coming through. So in multiplication and division, we're looking at the fewest sig figs overall. So the first number has 4 sig figs. Second number has 6 sig figs. The answer of that parentheses portion only has 2 sig figs. Remember that 0 is not significant. So therefore, our answer should only have 2 sig figs. So that means we're going to stop after the 2. And because that next number is a 7, we're going to round that up to 53 as our final answer. And then last but not least, that last problem here, we have 14.84 times 0.55. Again, multiplication, we're looking at the fewest number of sig figs overall. So that gives us 8.162. If this were the end of the problem, we would say, well, there's 2 sig figs, so we would stop after the 1 and round up. However, this isn't the end of the problem, so we're just going to mark where we would have stopped, but carry all the numbers through to the next step. So now we're taking 8.162 minus 8.02, and that ends up giving us 0.142 as our answer. When we apply that last step of significant figure rules, we know that in subtraction, we're looking at the fewest number of decimal places. So this new number that's from the parentheses only has 1 decimal place versus this one has 2 decimal places. Therefore, our answer should only have 1 decimal place. So we stop after the 1. And our answer would just be simply 0.1. This is one of those examples that if you would have rounded up at the beginning and said 8.2 rather than 8.162, you would get a different answer in this case. And so make sure when you're doing any rounding, you reserve that to the very end. I hope this video helps you understand significant figures and how to use them in calculations. Stay tuned for the next video. We'll be talking more on different topics of Gen Chem. Talk to you guys later. See you soon. Bye-bye.